A slot to a 63 finish. This module will explain basic surface finishes and show how a specific finish may be obtained. Sometimes a working drawing will call out for a certain finish or texture on a machine part. This finish must pass required quality control standards for the part to be acceptable. Many factors are involved that determine the grade or class of finish that may be obtained. These include type of material being machined, rigidness of work setup, cutting tool to be used, spindle speed, table feed, and of course, the skill of the operator. This is the symbol that is generally used on working drawings to indicate that a specific surface finish is required. It may be drawn with or without the horizontal extension line or the wide leg. Before starting, it's necessary to be familiar with basic preferred roughness values. Preferred surface finishes usually range from a 500 micro-inch finish, which is a very rough, low-grade machine finish resulting from heavy cuts and coarse feeds, to a 4 micro-inch finish. The 4 finish is a very fine finish, obtained by lapping, honing, or very fine buffing. A 125 finish is considered a standard machine finish and should be used unless a specific finish is called for on the working drawing. In this module, we are going to show how to mill a 63 finish. There are a number of different surface checking gauges available to use as a comparison to check the work. The operator can make either a visual inspection or use a fingernail to scratch both the work and the gauge, then compare by the feel. Before beginning, it is important that the vise is aligned. Then mount the workpiece in the vise. Tap it with a soft-faced hammer to seat it securely on the parallels. Install an end mill in the spindle and face the surface of the work. For this operation, it is necessary to use an edge finder to locate the exact edge of the work to be able to properly locate the slot. Mic the end of the edge finder. Note, the edge finder is divided into 2 parts. Measure the smaller of the 2 parts. Select the proper collet and install the edge finder in the spindle. Measure the width of the workpiece. You did deburr it before measuring, didn't you? Position the edge finder close to the edge of the work, approximately halfway up the length of the small end of the edge finder. It is a good suggestion to put a light coat of oil on the end of the edge finder. This is also a good time to offset the end of the edge finder from the body, if it is not already offset. Turn on the machine and set it at a medium RPM. Watch the edge finder. It will look like it is wobbling because the end is offset. Slowly turn the saddle feed handle and move the work into the rotating end of the edge finder. As the work moves into the edge finder, it will start turning straight. Keep moving the saddle slowly until the end of the edge finder kicks out from the shank. Stop moving the saddle the instant this happens. Look at the micrometer dial on the saddle feed handle. It is calibrated in thousandths, with 1 complete revolution of the handle equal to 200 thousandths of an inch. Loosen the micrometer lock. Set the dial to 0 and secure it in position. Back the edge finder away from the work and again move it in until it kicks out. Look at the dial. If it is on 0, the setting is correct. Turn off the machine. Before you go any further, here's some simple arithmetic for you. Take the diameter of the edge finder, which is 500 thousandths, and use just half of that, which is the radius. Mark 250 thousandths on a piece of paper. Next, take the width of the workpiece itself. In this example, it is 2.500 thousandths. Mark half of that, 1.250 thousandths, onto the other figure you have written down. Add the two figures together. The answer to this problem is 1.500 thousandths. Lower the table until the workpiece is clear of the edge finder. Then move the saddle out a distance that is equal to the figure you just found. This will position the spindle directly over the center of the work. Note, rotate the handle counterclockwise to move the work toward the front of the machine. Reset the saddle micrometer dial to 0. Lock the saddle in this position. Remove the edge finder and collet and install an end mill in the spindle. It is recommended to always use an end mill that is at least 30 thousandths of an inch less than the width the finish slot must be. This will leave enough stock on both sides of the slot for a finish cut. Turn on the machine and raise the table until the cutter just touches the top of the workpiece. Set the knee to 0, move the work away from the cutter, and set the depth to approximately 30 thousandths less than the finished depth. Lock the knee. Rough cut the slot through the workpiece. It may be necessary to make more than one pass to bring the slot to within 30 thousandths of the finished dimensions. Deburr the edges and clear out the chips. Then use a depth mic and measure the depth of the cut. Measure the width of the slot. Use a micrometer and measure the distance from the edge of the slot to the edge of the work. Measure both sides. If the slot is not in the center, an adjustment can be made when making the final cuts. Raise the table to the depth the finish slot must be, and again be sure to lock the knee. Move the table out 13 thousandths. This should leave approximately 2 thousandths for a finish cut. Make the cut. Take a cut on the opposite side of the slot to bring it within 2 thousandths for a finish cut. Increase the spindle speed by 1/2 of the speed used to cut the slot. Move to the back of the slot again and take a 1/1000th cut. The next step is extremely important if the desired finish is to be obtained. Move the table out 1/1000th and make a climb cut to remove the final 1/1000th of an inch. This is one of the few instances that an operator will make a climb cut on the vertical mill. Caution, never make a climb cut of more than 5/1000ths of an inch. A good shop tip is to make 2 additional passes without changing the table setting. This will compensate for any possible deflection of the cutter. Repeat the preceding steps on the opposite side of the slot. When complete, compare the finish with the appropriate section of the surface checking gauge.